Hello team, in this challenge we do matrix rotate, which is where we're given a matrix like this, or more appropriately like this, an array of arrays, and we are asked to rotate the numbers clockwise. So the 1 becomes the 2 becomes the 4 becomes the 3, and so on, etc. So we get this right here. In order to do that, there are a couple steps, but shouldn't be too difficult. Let's jump right into it. So right here, we are going to take this matrix and operate directly on it, okay? Using a reduce. So a reduce will return something that is brand new. We aren't actually going to change the matrix itself, but reduce will return a brand new array that hopefully has all of our changes in it, okay? Reduce takes two things. So we get the accumulator, we get the current, and we send it in. Now our default thing is going to be an array. That's what we're going to update. Okay, we're going to add things to this array, and then that is what's going to be returned, which is returned from the function. So good work. Okay. Down in here, we always return the accumulator. If you don't return the accumulator, it gets ugly in a hurry. Okay. I can't tell you how many times I've forgotten this step, and it always burns me. I go into the console, and it's like, oh yeah, I forgot to return the accumulator. So doing that early. And then in here, we can do the current dot for each. With matrices, I've said this before, I'll probably say it again. We're always in it for two loops. One for the rows, one for the elements, right? Every single time we have to do two loops in order to get that done. I've never been able to reduce it down to a single loop. It just doesn't work. It'll either be two maps or a reduce and a for each, or some sort of combination of multiple loops. Even a for loop inside of a for loop, you need two, okay? So for us, we have that reduce. We're going to do a for each in here, okay? That means that we have our element, our index, just like this, and we do stuff. Now, the for each doesn't have a return, but we can operate on each of these. And what we do in here is we take that accumulator at the index, and we shove our element into it, okay? So in order to do that, we're going to take that element, and then we are going to spread accumulator index, okay? Now, there is a chance, right? This is empty right now. Our starting array has no elements, which means that accumulator index, whatever the index is for that accumulator, might not exist. So right here, this second accumulator index bit, we're going to wrap it in parentheses, add a question, and toss in an empty array. At which point it works, right? And it works brilliantly. We've reduced it down, and we have used that index to slide this element into the correct row. The index relates to the row, okay? Not to the element. So all of this kind of twists. It twists sideways. And because we put the element first, it goes in the right place, at least for clockwise. Now, before wrapping this up, I do want to take this a step further. And the step further is I want to make this flexible enough to go clockwise and counterclockwise. I want to do both, okay? So right up here in my arguments, I'm going to set a default argument of dir equals CW for clockwise, okay? Spaces are allowed. Doesn't matter, okay? Now this direction, we are going to use it down here. I want to keep using index, so I'm going to change this one to an I because we are going to create a new index, okay? In order to change it the other way, we need to do some funky math, right? We need to work from the end of the array, not the beginning. And in order to do that, we need to do some subtraction. We need to get the length of the array, a few extra steps. But that's all based on this direction. So right here we go const index equals dir equivalent to CW. Notice the 3 equals, right? This is a single equal. This is 3 equals because now we are doing a comparison, right? And if it is that, then we return I. Okay, that's this one here. We just return I, which means that this should work. Otherwise, we need to do some stuff. And for this, I'm going to add array. Could I just use the current element directly? Yes, but I like to be able to extract this at a moment's notice. So array here, which means that array.length minus 1 because the length is always greater than the last index, right? We need to get that last index, and then we need to subtract the current index. So we're working from the opposite side to get it styled in, okay? This still works, but we aren't done because right here, we need to change this bit, okay? So cutting this out, same sort of thing, dir triple equals CW, capitalize, because that's how I did it. And if that's true, then we get the same thing. Otherwise, we flip it, okay? So we take that element, cut it away, clean this up, add a comment to the end and the element, and everything still works. We have no way of testing this, at least not here. But what I've done is I've taken this exact code and moved it to a code pen. Okay, so this is that exact same code. For some reason, I was creating a new array. We don't need to do that, but tossing in that matrix, again, controlling it with the direction, we get a, whoops, did I drag something around? I hope not. Good, okay. If the direction is clockwise, we just get our index. Otherwise, we get our index from the other side, okay, from the end of the array. At which point we use that information as our index down here. And if it is clockwise, then we put the element at the start. Otherwise, we put it at the end. This is the exact same thing, only we have a different value for direction here. And if I run this, it should, once it's done, it should work. So 1 goes to the right, okay? And for the counterclockwise, this one here, 1 goes down. It goes to the left, counterclockwise, okay? And the only danger here is that I didn't actually lock these values. So I could actually put anything in here, right? And it will still work. So long as it's not capital C, capital W, it all still works. So a little bit of something there, right? I probably need a little bit of extra protection, but this works today, okay? So jumping back, we did it, right? We took that matrix, we looped through each individual element based on the rows, right? Current, could have changed current to row, just like this. It still works, right? If that helps in your head, right? To know what you're talking about. The rows, the elements, and then funneling those elements into the right place inside of the accumulator and sending it out the door, okay? And because we made it a little bit more flexible with direction, if we ever need this in the future, well, we have it, right? We can just go and grab it, copy and paste it forward, and make it work. Again, not every solution, just one good solution. If you found another, I've seen a few out there, and some of them are harder to read than others. I really like this because it makes sense in my head, but maybe not for you, right? Let me know in the comments. Let me know if you found a different way that you think is cleaner or easier to read, right? All that good stuff. Otherwise, for this challenge, this has been Matrix Rotate, and I'll see you in the next one.